we want to take a look at how much carbon dioxide is produced by the world's population breathing. And we'll do that in the first part. And in the second part, we'll take a look at, we'll have a little discussion as to whether or not the carbon dioxide we produce has any climate effect. In order to do this, we have to come up with a way of saying what the energy is that we take into our bodies during the day and how much carbon dioxide we would produce from that. So we'll do a very simple approach to this, and we'll consider the case of sugar. We'll have C6H12O6 for the sugar, and in our bodies that will combine with oxygen, and that will produce carbon dioxide, and that's what we're after to look at how much we produce, plus water, plus energy. And the trick to working this out in a sense is to figure out what the energy is. Well, let's balance this equation first. We're going to need a 6 here, a 6 here, and a 6 here. So how can we come up with an amount for the energy? Well, if you take a carbon atom and you combine it with an oxygen atom, you will get CO2 plus energy, and it'll be 4.1 electron volts for the interaction, for the combination of the carbon plus the oxygen. One carbon atom, one oxygen molecule. And for each carbon atom, you'll get that amount. So what we have here, we have 4.1 electron volts per one carbon atom. And in the case of sugar, we have 6 carbon atoms, and 1 mole of sugar will contain 6.02 times 10 to the 23rd carbon atoms. And so we have the carbon atoms canceling now, and that's per mole of, so that's 1 mole of the sugar plus 6 moles of the oxygen. And we want to convert the EV to joules, so we multiply by, put 1 EV here, and this will be, let's see, 10 to the minus 19th joules, and the factor that we want is 1.6. And so now we have the number of joules. It's better to have it in kilojoules, so we'll multiply by 1 kilojoule over 1,000 joules. And that will give us, if you work this out, for this chemical reaction, the energy that will be produced will be 2,400, roughly 2,400 kilojoules. And if you look it up exactly for this expression, it's more like 2,800. But I think it's more fun working it from here, realizing for each carbon atom that interacts with the oxygen, you'll get 4.1 EV. So we get 2,400 kilojoules. So we're going to keep that number. So this energy over here is 2,400 kilojoules. Now, we need to take a look at how we can convert an intake of the sugar to calories and energy. So let's say that on average, any person in the world, if you don't like this number, you can easily reduce it. Let's say they take 2,000 calories per day. And each person does that. So that's one person, one day. So we have a diet of 2,000 calories per person per day, and we want to convert these calories over to a weight in carbon dioxide. So how are we going to do that? First thing we want to do is we want to convert the capital calories, which is the way you measure food with the capital calorie. So we have one capital calorie, and that's the same as 1,000 calories. And now we want to convert the calorie to joules. So 1 calorie is 4.184 joules. So now we have converted the calories to joules. Now what we need to do is work in the carbon dioxide. So what we know is that 1 mole of the sugar with 6 moles of the oxygen, we know that's going to produce 2,400 joules. Okay, all these factors here I'm basically multiplying by 1. So we have 2,400 joules. Now what we have to do is convert or look at the amount of CO2 that we get. So we're going to say that the 1 mole of the sugar plus the 6 moles of the oxygen are going to produce 6 moles of CO2 plus 6 moles of the water. So that step we get from this equation here. Now what we need to do is look at how many grams are in this. So we're going to move back over here. We're going to multiply that now by how many grams there are in that mole. So in those moles, so we have 6 moles of CO2 plus 6 moles of H2O. And how many grams is that? Well, the CO2, we have a factor of 6 common to the CO2 moles. It's supposed to be a mole there. And the water. So we'll have 6 times. Now the weight of the CO2 will be the carbon plus 2 oxygens, and that works out to 44 grams of CO2 plus the 6 moles of the hydrogen. So that's going to be 2 hydrogen plus an oxygen, and that'll give us 18 grams of water. And now what we're interested in, what the amount here is for the carbon. And so what that is, we have 44 grams of the carbon, CO2, of carbon dioxide over the total amount of 44 grams CO2 plus 18 grams of the water. And we can convert, so now we actually have a weight in grams, but it would be nice to have the weight in tons, because you can see it's going to be a large number. We have to multiply by the world population yet, so it will be a large number in the end. So to convert the grams over, we remember that 454 grams is 1 pound. And 2,000 pounds is 1 ton. And we want to convert the day to years. So we're going to have 365 days over 1 year. And then we want to take care of the fact that there's so many people in the world, and the number that we'll use, we'll say that there's 7.4 times 10 to the 9th persons, and that makes up the one world population. So if you multiply this all out through, you'll find that the number of tons produced by the world population is 2.7 times 10 to the 9th tons CO2 for the world population in 1 year, per year. So it's roughly 3 billion tons. And now let me just summarize this over here on this chart. You can do a print screen on this chart if you want. So what we're showing is the reaction that we're using, the simplification of using sugar as the fuel for a person. That's the chemical reaction. And each carbon atom combining with an oxygen molecule will produce 4.1 electron volts. You can convert that for the 6 moles of the carbon atoms and find out that the energy that's produced is 2,400 kilojoules. And the true value is actually 2803 kilojoules for that reaction. And then these are the steps of converting those calories to a weight for the amount of CO2 that's produced by the world population in 1 year. So that is a large amount of carbon dioxide. And the question then is, does that contribute somehow to an increase in carbon dioxide in the atmosphere, which could influence climate change? So the question that we want to ask does world population production of CO2 influence the climate somehow? And the answer is no. And the reason for that is kind of easy to see. So here you are, and you're breathing CO2. The CO2 goes into the atmosphere. There are plants growing. They absorb some of the CO2. And in the process, they produce carbon like in a sugar. And then we eat plants. And also, the plants get eaten by, say, a longhorn steer, and we eat them. And some plants get eaten by chickens. And we eat chickens. And there's also fish. So the carbon that goes into the plant goes into the animals, and eventually that carbon comes back to us, and then we produce the CO2. So there's a cycle here, and it's basically a closed cycle. And because it is a closed cycle, there's no new CO2 being introduced. So the CO2 overall will not increase. It will reside, in a sense, in a way, in the plants and the animals, and then in us, and then we exhale. And of course, the animals are also exhaling. And another thing that happens with plants is if it's corn, you can produce methane from the corn. And then what happens to the methane? It goes into somebody's car. As fuel. And then out the tailpipe comes the CO2 again. So that too, that's just part of a closed cycle. In order to increase the CO2, you have to have some sort of different process. So you have an oil well over here. There's oil down below. It gets pumped up. It gets transported to places. You use it in your car. You use it in factories. Use it in many different ways. And that does add CO2 to the atmosphere. But human metabolism does not. So that does not add additional CO2 to the atmosphere. But it is a very large amount of CO2 that gets cycled through that process. And again, it's approximately 3 billion tons of CO2 for the world population in 1 year. So that's how you can calculate the amount of CO2 produced by people all over the world eating roughly 2,000 calories a day. And if you want to change any of those numbers over on that chart, you could do it, but we came up with roughly 3 billion tons of carbon dioxide.